My name is John Boggie, and I'm the head of Cybersecurity Certification at NXP. And what I wanted to do was to talk about the revolution that's happening in IoT, talk about how systems are evolving and what that means for security. And at some point, I guarantee you'll see some slides of doom, as I always like to call them, where I talk about how we're all doomed and everyone will die. And then talk about what's happening in legislation. So some of the previous talks mentioned about the CRA, but there's other pieces of legislation around that are happening, and really what that means, and also to talk about some possible solutions for the tsunami of legislation that we see, and how we can make that easy as an industry and not explode the costs, etc., for companies. So let me start off with the IoT revolution. Now, I'm sure you've seen lots of slides where it talks about the hockey curve of, in the year 2020, whatever, we'll have 50 billion devices. But actually what's happening now is these things are actually happening. And the technology that we've been developing over the years, not just us, but the people who are working on software, the people who are working on AI, real-time computing, all of these networks that are, getting more and more data, huge amounts of data getting pushed around. And this is all happening right now. And when we have these figures here of 2026, 2025, that's technology that we've been developing for the last 4, 5, 6 years if you're a hardware manufacturer. And to sort of illustrate what the revolution looks like, I wanted to kind of talk about 3 key sectors that we in NXP Semiconductors play in. First one is the automotive. And the way that automotive is going is previously you jumped in your car, you drove somewhere, you had an infotainment system, you may have some flashing lights that you go, what's that? Oh, my brakes are still on, whatever. But in reality now what's happening, especially with things like the software-defined vehicle, is that the car is becoming more or less like a robot, and it's becoming a thinking, sensing machine. So instead of having that discrete component, you now have something that's connected to the cloud. And in the cloud, more and more is a digital twin. So all of those buzzwords that you've heard about before, you'll have a digital twin, which will be modeling your car. And it'll be modeling the performance of your car, also where the positional place of where your car is on the road, and making minor adjustments. So making adjustments on the way that you drive to make sure that your brakes, for example, don't run out quickly. All of these things are happening now. Digital twinning, and also your car can sense when you get in. It's you that's there, it's not your wife, it's not your 4-year-old child. And it adjusts to exactly what your settings should be for that car. And obviously with the digital twin in the cloud and the machine learning, both at the edge and also in the cloud, it can adjust also to your driving skills and whatever the way that you drive. Too fast in my case. This is also the case with industrial. Industrial is one of those things that we forget about. It just kind of happens. And then we had COVID and supply chains started to crash, and everybody started looking at industrial and water filtration plants, all of these things. And the numbers and the carbon footprints of industry is immense. So for example, unplanned downtime costs 1.5 trillion a year to the worldwide economy. Waste, 50% of global waste is down to industrial and manufacturing plants. And this is where this new technology and the things that we have now is coming also into play in industrial. So if you think about an industrial plant, and if you think about the amount of data and data gathering that happens, what you can do is you can reduce the footprint of your plant. So you can turn production lines on depending on the input data about whether the certain commodity that you need is expensive or cheap. And you can turn on lines according to that. You can also very easily see what consumers are buying and then decide whether you reduce that production line or maybe ramp up another product. And also the safety and security within these factories, because what you have to think about is that these are critical infrastructure. So every single plant, manufacturing plant, can be considered as critical infrastructure. If you're producing bottles of water and the water supply goes off, suddenly you're very, very important. So every single part of this is critical infrastructure, and it must be secure. And also the same with safety. You can now, within a factory, you can have ultra wideband on each of the piece of machinery, and you can also tag your workers. So you stop having that accident where the forklift accidentally backs into one of your employees, because you can see the positional data there, and your machine learning in that plant can suddenly stop that car. Also in the smart home, this is traditionally what we think of as not so important. But in reality, this is now something that we are more and more reliant on as we move forward. So I can guarantee this isn't some rich guy's house anymore. This is your house. So I can guarantee if I go into your house by breaking through your door lock that you thought was secure, if I go into your house, I can look around and see already all of the edge components you have there that are connected to the cloud and to these various services. And one of the biggest sea changes that happened recently was the whole Matter, Connectivity Standards Alliance Matter. I'm Scottish and I could stand and speak Gaelic, or I could speak French or whatever, and half of the audience would not understand a word. I know just speaking Scottish, half of you don't understand what I'm saying. But if I was speaking in a foreign language, that would be strange, because the business language in the world now is English. Matter is the business language for IoT products. It's a handshake and an agreement, so that if you bring your light bulb in and you connect it, it connects to your Google Nest, it connects to your Alexa, it connects to whatever. This interoperability standard is a key thing to make that connected home into something usable. So in reality, what does this all mean? And it means simply this. If we take that interoperability standard and we take that and we utilize that across all of those various sectors I've talked about, then when all of these things are talking together, I can have a seamless life. I can get up in the morning, my coffee can be ready for me, the music I was listening to yesterday can start from exactly where I was. I can walk out to my car, it turns all of the lights off in the house and locks the door, and the music I was listening to starts in my car. And my car can take me to work, and these things can carry on and on. And also all of that data that's getting carried can be used also for factories, for traffic control, all of these things. We have the technology now to make this happen. And it's just a matter of us connecting this up, but it's happening rapidly. Now for the slides of doom. So, hackers. So basically, the problem is when we connect everything up, and we connect it in the way we have at the moment by simply plugging things out in, not understanding what the security are of these things are, what's actually in that product, we start to have problems. And hackers are exploiting this. Ransomware attacks are on the rise. Every 11 seconds there's a ransomware attack, probably quicker than that now. This is what it looks like in reality. This is a graph showing deployment of IoT versus cyber incidents. And you can see it's pretty much one-to-one. As we connect things up and we deploy more, cyber attacks are happening more. And these things are state-sponsored. We see that in the press. I'll not name any countries, but say there was a large USSR-based country that was attacking another country, then they may be doing cyber hacks on all of the people who are supporting them. Simple things like software bugs are exploitable. Simple things like bad engineering are exploitable. Things like not changing your password becomes exploitable. And also we see it once things connected up, you can have these various botnet attacks, and these are actually happening. It's not something that's we've talked about in the past. Hey, there could be botnets. There is botnet attacks, and they're happening now. So let's go back to that curve where we deployed technology and the hacks went up. And let's look at something comparative. Let's look at the automotive industry. As we deployed more and more cars into the marketplace, something spectacular happened. Deaths went down. So as we deployed cars over and over the years, actual deaths on the road dropped, and they dropped dramatically recently. And this graph actually goes further down. And the reason we did that was because we as an industry worked together with legislators and with standardization groups to ensure that safety was front and center in everything we did. So we had all of these things like legislation. Hey, don't get drunk and go in your car. Law. I know, who knew it? But these sort of things started to help stop that deaths. Also, the fact that you have now advanced driving systems, even if you don't have that lane guidance, just notifying there's a problem that you're drifting out of a lane has dramatically dropped those deaths. Also, industry best practices, things like the UNE R155 that's come in, has also meant that security is taken into account, ISO 21434, and also the safety standards. Better. Now, so regulations and security standards. Somebody, you remember when I said that slide of doom? Let me show you the actual slide of doom. I asked one of my team to, could you map, if you were an IoT manufacturer, what regulations and standards and rules look like worldwide? And he produced that. If you are producing something right at this moment and you want to deploy it worldwide, this theoretically is what you have to match. Terrifying. And even when I go into the EU, where I see a little bit more joined up thinking there, it's still a plethora of regulations that are overlapping. So when we look at all of this, we try to find something here that makes sense and something where we can make that kind of universal. And some of these regulations that you saw before overlap. And so by looking at these key critical pieces of legislation, we can have a fair punt that we cover most of the stuff worldwide. The ones that a couple of people have talked about recently are the Cyber Resilience Act, and I'll go in a little bit more to the Cyber Resilience Act, but there's also the US Cyber Trust Mark, which is a labeling scheme that is now getting proposed. And also there's other regulations, for example, PSTI in the UK. And PSTI is very based on the ETSI standard 303645, but also with some of the CRA and the cyber labeling. This kind of talks about those things. I won't spend a lot of time on this, but there is very much similarities between the US Trust Mark and also the Cyber Resilience Act. And that carries on with those kind of rules and regulations. The way that I think about this is Cyber Resilience Act is GDPR for security. And when you think about it like that, the actual ask is, hey, you manufacture security products, you own the security. If you don't own the security of it and you fail, we will fine you or we will take your product off the marketplace. So we will use regulations like the RAPEX laws to end of life your product, whether you like it or not. And you know, there's different, I mean, it looks at things like product configuration, access to the product, data protection, all of these things. But it really doesn't talk about how do you do this? How do you match this? So there is no real requirement there for a certain certification standard or whatever. Things like crypto, yeah, great, deploy crypto, make sure it's secure. We don't care what you deploy. And the other thing that a couple of the presentations missed, which I think is very important, is if you believe the Cyber Resilience Act does not include you, you are wrong. Very, very fundamentally wrong. Because it talks about other sectors like automotive and medical, and it says if there's regulations there, then they are what you follow and not the Cyber Resilience Act. That's fine if you're an OEM. If you're a component manufacturer, a subcomponent manufacturer, the CRA is the first thing you need to match. Now, if you have something like ISO 21434, it may match all of the requirements of the CRA, but the CRA is still being written, so we don't know. And this is the kind of one that the previous two presenters talked about. It's really based on risk. So it's based on the risk associated with that type of product. So it goes from those things, the light bulbs in your house, all the way to perhaps something that's in critical infrastructure or something that's used by governments. And I'll come back to that. I'll come back to that slide again once I get onto this. I won't go into, but basically it also talks about the life cycle of the product. So it demands that you think about the product when you're developing it, about security. You look into making sure there's no common vulnerabilities. You make sure that there's no known vulnerabilities that you are producing the product. You make sure the user guidance and the security guidance are very easy to use. All of these things. And then when the product's in the field, it just doesn't lie there. You also have ownership. If there is any security problems, you need to notify customers, stakeholders, and believe it or not, governments. Please don't throw things at me right now. I know how terrifying that is, but also governments. You need to explain that too. So how do we manage this in NXP? What I've talked about now is all of the problems, and I've seen other presentations where they talk about the problems. I haven't seen very many people talk about what the solution is. And as an industry, we have all of those things that I talked about with automotive, about regulations, about self-standards, all of these things we already do in our sector, the semiconductor sector. So we have embraced certification for a long time. We've embraced standardization for a long time around security. So what we need to do first is we need to look at those legislations. We need to find the important ones. So things like 303645, if you're an OEM, that's a must. That's something you need to look at and you need to follow. It's also deployed in places like Singapore, in places like China, Finland, and places around the US. The cyber labeling also takes this into account through NIST 8459. So that's an important one for you to look at. Cyber Resilience Act, you ain't going to get away from it. You're going to have to match it. And even if you don't think that Europe is that important a market to you because you've gone through Brexit, sorry, Scottish. Even if you don't think it's that important a market, it's something to realise that this will be the foundation that the other legislations will follow. Compliance. We need to make sure that international standards are utilised. So it can't be that we rely on people like Senelec or we rely on ETSI coming and telling us what standards to use. We need to make sure that the Commission understands these are the practices that we have and we would like to reuse them. And this is really essential for the SMEs and the startups, because if it is new standards, then they have to find the expertise to be able to do that. If it's existing standards, the expertise is out there, even if it's consultants, but it's all there, so we need to utilize that. We need to make sure that the good guys are not punished. So it's great that we say, hey, everyone needs to do a step up. If you're already there, double regulation is a nightmare because you're already doing something in practice, then you have to do something additional on top. That becomes damaging to companies. And most importantly, we need these regulations and standards to work together. Because if it doesn't, if we do it on components, somebody does it on the software, somebody does it on the web, products then become very costly and services become costly. And that's something we don't want in the marketplace. This is how I handle this in NXP. So in NXP, we use a holistic approach to certification. For me, there's three types of certification. There's an information security management system, which is basically what is the mindset of your company with regards to security. We also do We also do a secure development process. So we also make sure that our development processes have security by design. We have security architects. We have gates around everything that we do around security. And finally, we do product certifications, and we do a crazy amount of product certifications. I think security certifications last year, we did 300 plus certifications. So already, and if I take that and I go back to what happened before, where I said about the default category, the class 1, class 2, and critical, I can take all of those certifications that I've done and use them to match each of those categories. And that's something that makes me proud, because I've been working on that for a long time. And to get to that where I can look at the CRA and say, hey, I'm going to match this. This is also something that we'll present to the Global Semiconductor Alliance, and we'll probably do some white papers and deliver them to the Commission to explain to them how our industry have this already in control and how we can explain that to the SMEs and the startups. We use a standard called CSIP. The previous presenter mentioned it. CSIP is a certification standard that we developed with Global Platform and with other companies like TrustCB, SGS. And the idea was to make something that was more cost effective and simpler for manufacturers to use. It's nice and flexible. It's at services, so it's at API, APDU level, which makes it very easy to build on top of. So you can take a CSIP cert and you can put your own layer on top and reuse the results from below, which makes sure that it doesn't explode the costs for OEMs. It's now a European norm, so it's an EN 17927, which means it's an open standard. So it's also something that is within Senelec, so it's in the European scheme. And because it's nice and open, we can use it to generate things like protection profiles for any standard that's out there. We've done it for things like Qi charging, NFC controllers, whatever, Matter. One of the most important things on it is that you also end up with a report that can go directly to customers. And the report is quite simple. It talks about the testing that you've done on your product, what your claims were, the APIs you claimed, and how that was tested or verified. You can also pull in other things like ISO 21434 compliance, 62443, and you as a vendor, a tier one or an OEM could store that as an artifact. So if there is any liabilities or any issues around CRA, you can show that report and say, hey, at product launch, we tried to do everything possible to show that there was no vulnerabilities. It also takes into account things like our PCERT processes, etc. So that's also covered, which is mandated by the CRA. Quick presentation about how awesome NXP is. If anybody doesn't know who NXP is, what? Where have you been? So, but we're awesome, apparently. And if you can, please buy lots of our products. They're really good. And it's all backed up with a CSIP report on the critical ones. If you need to know any more about NXP and security, go to our website, look at it. It's awesome. Just let us know how brilliant it is. Please don't criticize things because I don't have the time. Does anyone have any questions? Okay, cool. Thank you.